Hello everyone, I'm Paul and today we're solving problem 1863, sum of all subset XOR totals. So we are given an array nums and we are trying to return the sum of all XOR totals for every subset of nums. Okay, so first we can see the constraints and here and we see that num's length will never exceed 12. Also, we need to get every subset, okay? So, given these things, we can think about backtracking. And each time we get a new subset, we can just get the XOR total of that subset and add it to the result. So now let's talk about backtracking. Let's say we have this array at nums 5, 1 and 6 and we want to iterate over every index. Let's start with 5 and each time we will either take the value or not take the value. So there's a word somewhere in which we take this 5 and we get an array with 5. And there's a world in which we don't take 5 and we have an empty array. Then we move to the 1, to the first index, and here we can decide to take the 1, so we'll get an array with 5 and 1, or we don't take the 1 and we keep our array with 5. Similarly, here we have our empty array. We can take the 1, so we'll get an array with the 1, or we can keep our empty array. And here we are in another level, so we are now working with the 6. In the array with 5 and 1, we can decide to take the 6, so we'll get 5, 1 and 6, or we don't take the 6, so this would be 5 and 1. Here also we can take the 6, so we'll get 5 and 6, or we don't take the 6, so we'll get an array with 5. Here we can take the 6 and we'll get 1 and 6, or we don't take the 6 and we get our array with 1. Here we get our array with 6, or finally our empty array. So these are all the subsets we need to work with. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 subsets. And for each of these subsets, we'll get the XOR value of the array and we will add it to the result. Time complexity for this one will be big O of 2 to the power of n, because we either take or not take every value on the array. And space complexity will be big O of n, if I'm not wrong, because we are using only an array to store each subset and we are backtracking, so we are popping values from the array. So I think big O of n is the correct answer for space complexity. So now let's go with the code and hopefully you will get the overall idea. So first we say result equals 0, and now we want to create our backtracking def dt, and this will take two values, our start index and our current array of values. And finally we will call this backtracking function with an index of 0 and an empty array, and we will return our result. So we only need to complete this function now. So let's get to the core of backtracking first. We want to create a for loop for I in range from our start value, okay, up here, from the start value to the length of nums, and each time we want to append our current nums value to our current array. So car append nums I, and then we want to call backtracking again with an index of I plus 1 and the current array. And this is where the magic happens. We need to backtrack here. This means we need to pop this value that we added here in order to cover all the possibilities that we have seen before. So car.pop. Okay, so this is the core for this function, and every time we start a new iteration, we want to do the following. We want to get the XOR value of our current array. So we'll start with a value of 0, and for every value in our current array, we'll say value XOR X. And we want to add this value to our result. And to make this work, we need to put here non-local result, because result is outside the function. So this should be it, and this should work. Let's see what happens. So I put a 1 here, and it should be an I. So now it should work, and it does. So if you found this useful, please drop a like and subscribe, and see you next time. Bye bye.